Um, do you want paper at all, or are you good without paper? Okay. I'm going to bring you a tablet to use. That's for you. You can count on them. Feel free to eat as long as you want. You're welcome to eat here. And then we're going to talk about these some. And what I'm going to say is, hey, you know what? Go ahead, Corinne, and don't grab. Write out the domain and range for me. As let me give you just a helping hand with this first one. I'm going to say, hey, go ahead and give me the domain, give me the range, and don't forget to put braces down for domain and range.
Wait, do you want me to solve the domain as an inequality?
No, in this case, all I'm asking you to do is write out the domain and range, right? And here's a good question for you. You're given a table here. You see the table to your left? Obviously, you see the table. Are those discrete points or are those continuous points?
Discrete.
Why are they discrete?
Because they're not like continuous.
Yeah, in fact, they're not put on a graph with a line already through it.
Yeah.
And also, an inequality, if you were given an inequality, it would suggest that it's continuous. So would you want to write these in an inequality? No, because an inequality says it's continuous, where this table says, hey, these are discrete points. You got it?
Yeah.
So if you were to graph this, would you put a line through it?
No.
Not at all. And would you want to write it in an inequality? No. Not at all. Cool. I think you got this one down. Hey, quick question. Is this a function?
Yes.
Yes. And why is this a function?
Because there's the y's. At every x only has one y.
Exactly. Cool. So let's go to the next one here. Let's scroll over for you. Can you write the domain and range for me here? You might want to click on the color again. Oh, the power's on? No, it should be. I think it would be working if the power is on. Try that. Oh, there you go. Cool. So here's my question here. All I want you to write is yes or no. Go ahead and write yes or no. Why is that not a function?
Because negative 5 is the y's for negative 5 is cubed root of 4.
So you're telling me that you have more than one value, y value for each x, right?
Yeah.
Each x is more than one y value, doesn't work out. Cool. So this next one, you don't have to write out the domain and range. I think you get it. But tell me, is this the function here? Well, you're working out the same too. Function. I'll let you write out what it is. And why is that?
Because each x still has a y, but the y is repeating.
Yeah, it doesn't matter if this is repeating right here. You just told me the x's are all different values. So each x has a different y. Hey, so what we end up getting, in the long run, and I'm going to switch topics here, okay? We're going to start talking about arithmetic sequences. And these are a special type of function. And the cool thing about this is the first thing you need to do, what's arithmetic? When you hear that term, what does it make you think?
Like numbers.
What types of numbers? So what are you doing with it, arithmetic? When you hear that word arithmetic, what are you thinking? What types of operations? Adding, subtract, just the basics, right?
Yeah.
Yeah, absolutely. So to have an arithmetic sequence, you need two things. First, the domain, so D, right? Domain also stands for your x values here, right? Well, they are all natural numbers. We've got to be the natural numbers. So what are natural numbers? They're any whole positive number. So natural numbers, think about when you started counting. The natural numbers were 1, 2, 3, 4, 5, 6, right? So we got x is 1, 2, 3, 4, and it goes in that sequence. So the first value is always going to be, the smallest value has to be a 1 here for x, the domain. The smallest value you can have as a natural number is 1. The second thing that you have to have is you have to find a pattern, okay? And the way you find the pattern is you say, hey, if this is my domain, go ahead and fill in these y values by rating. So you have to have a pattern. Do you see a pattern here? And I actually see one, but I'm wondering if you do. Yeah, -2. The difference between the y values is 0 minus 1. Sorry. You're saying that the pattern here is -2, right? Yeah, absolutely. So we see that there is a pattern here. Well, I bet that you could guess what the next values would be here, but we're not going to get into that right now. Basically, the difference is, so there this pattern is these are 2 apart, right? But you can also have a common difference in the y values. To have an arithmetic sequence, you need to have the domain to be natural, and you need to find a common difference in your y values. Well, what's the common difference here? Would be 0 minus -1, right? So what is that difference really? Sure. Plus 1, right? Well, what about this common difference here? 1 minus 0. 1 minus 0.
Oh.
Yeah, absolutely. So are you starting to see the common difference here? Yeah, 2 minus 1. So if you find this pattern continues, you're always going to find the common difference is 1. So if you find this common difference it's always the same pattern, it's always the same, you find a common difference, then in this case it's just 1. Then you have an arithmetic sequence, okay? So let's move down to the next part here. Let's see. Nothing there. What I'm going to go into next is to say, okay, so we've got this problem. Because you could figure out what the next values would be here, wouldn't you, if I drew this table out further?
Yeah.
5 and 3 is pretty simple, right? So we can keep carrying this out. Well, if you keep carrying it out, there is actually a formula for solving the arithmetic sequence. Say that you want to know a number that's way out there. Let's say like 71, right? Well, if you want to find 71's value, the nth value is what I'm going to call it, okay? Because maybe you don't want to find 71. Maybe you just want to find some number way out there. Well, did I give you a term to find? No, not really. So we're going to just call it the nth term. All right? It's a general term. I'm just saying n. Go find n. Well, what is n? Well, let's figure out what n could mean. Okay? So let's read this problem. Do you know what an odometer is?
Yeah,
It measures, it can measure your speed, but it also tells you the miles on your car. Okay, so what we're going to look at is the miles on your car. I should probably put an MI right here, okay? So miles for my car, and So the miles on my car, the mileage, well, right now it reads at 5,400 miles. I've driven 5,400 miles, all right? And that's what it reads. Well, what will the odometer read after 29 days? After 29 days, what will it read if I'm gonna add one more thing here. If my car only travels 50 miles per day. So each day it's only going to travel 50 miles. And it'll travel 50 miles, okay? So do you see a pattern here? A common difference? What would that common difference be?
What do you mean?
Let me draw the chart for you real quick.
Is it related to the top?
It's not related to this. It has, the only thing that it has to do with this is there's a pattern just like this. The only thing is we're going to turn this into an arithmetic sequence. All right? And the way to do that here is to say, okay, well, what does my odometer read on the first day?
5,100.
Okay. So right here, plug in 54. Here's my next question. What will it read on day 2? Yeah, absolutely. Yeah, absolutely. How about day 3? Yeah. How about day 17? Go ahead, calculate it out. Just kidding. I threw you off, right?
Yeah.
Well, hey, Corinne, this is a number that is way out there, okay?
Yeah, that's like 30 to 50.
That's one way. That's one thought. But there's a formula that works every time, okay? Sometimes it's not as simple as just 50, right? So what I want you to do is think of, hey, instead of finding that 17th day.
Teacher's point interruption. If we could have all cross-country students
Cool.
going to
So
District
instead of
B,
finding that
safely
17th
cross at
day,
this time
what I
and
want
walk
you to
front
think
to
of
meet
is,
Mr. Charles.
hey, what is after 29 days? What would 29 days later actually be as a term? Where would it go inside of the domain? 29 days after the first day is what? Yeah, so this is going to be, we're really looking for the 30th day. I could find the 17th day, but I'm not going to make you do it, okay? You could find it, but for now, let's just deal with the 30th day, because that's what the problem's saying. Okay, so the 30th day, well, there's this awesome formula, and the formula says this. And before I put on the formula, can you find a common difference for me here? Well, between these two values and between these two values, what would that common difference be? How do you know that? Huh? If I subtract this value from this value, I get 50, right? And also, the problem here told me, hey, after I always drive 50 days. Doesn't it say that? Cool. So you know that there's a common difference of 50. So I'm just going to give you a couple of pieces of information. The common difference, or I'm going to call it D, equals 50, okay? The difference here is 50. Also, this first term, well, this first term, I'm going to also, let me actually move forward here, because there's this awesome formula, and the formula says this. A sub n, remember n's that nth term? Well, what's the nth term in this case? So do a sub 30 there, okay? Write a sub 30 right below it. Cool. So I'm going to finish this formula and then you'll fill it out. So a sub n equals a sub 1 plus n minus 1 times b. Okay? So what I want you to do is tell me what's a sub 30 equal. Oh, by the way, a sub 1, well, this 1 means the first term, right? So what's a sub 4 equal? Go ahead and fill out that sheet.
Wait, so I don't multiply it with 3?
No, I'm telling you, take the information you have here and plug it in, substitute it for the values here. Go ahead and solve for that problem. Yeah. You can lift your pen real quick. If you go up here and just click undo. Maybe it saved it. Let's just start it over. So, base of 30 equals 5,400. Go ahead. I know it's wrong. You're clicking on the button. Yes. And that row might be columns in front of you. Let's try it. 30 Let's go one. Click on the pin up top or the brush. Click on one of those. Anyone that you want. And make sure you're not pressing these buttons on the side of the pin. You're okay. Take your time. If you calculated this out right here, I'm pretty sure you would get a number that's close to 6,800. Okay, but hey, this is part of the video tonight. I think we've got a solid idea here, Corinne. What I'm going to do, if you want to get this on video later, I'll save it as a video file. Okay? You have a flash drive you can just leave with me? Okay. I think you're doing good, though. Keep it up. Hey, let me see here. How far away is your other class from here? Here in band? I'll tell you what, just tomorrow, just remind me if you want a video. I'll give it to you, okay? Come in! Yes. Good.
I didn't understand how to do my one.
Yay!
Are we back in our normal seats? Yeah.
No, I'm a teacher. I don't help students.
I like something from a raffle.
What?